The National Electrical Code, or NEC, has requirements for headroom space above electrical equipment, ensuring the safety of personnel during work or maintenance. Section 110.34 of the NEC dictates that electrical equipment accessible to qualified persons needs a minimum headroom of 6 feet 3 inches from the finished floor or the working platform. Furthermore, Section 240.24b of the NEC requires dedicated equipment space for equipment likely to need examination, adjustment, servicing, or maintenance while energized. This dedicated space must be free from other equipment or materials that could impede safe operation or maintenance. Considering the proximity of a P-trap to a 277/480 volt electrical panel, even if the P-trap is not directly above the panel, its presence within the 6 foot 3 inch headroom space presents a potential hazard. A leaking P-trap could drip water or other liquids, posing a risk to personnel working on the panel. While awareness of a potential leak is a valid point, it doesn't override the NEC headroom space requirements which are in place to ensure personnel safety. Therefore, based on NEC code references, positioning the P-trap in a way that it infringes upon the headroom space violates the NEC. This installation poses a potential risk to maintenance personnel and should be corrected. To elaborate on Article 110, let's delve into the general requirements for electrical installations. This section of the NEC covers the essential rules and guidelines for ensuring the safety and proper functioning of electrical systems. Some key aspects of Article 110 include: first, approval, where electrical equipment must be approved for the specific purpose and installation environment. This ensures that the equipment meets recognized safety standards and is suitable for its intended use. Secondly, mechanical execution of work, which requires electrical installations to be performed in a neat and workmanlike manner. This includes proper support and securing of cables, raceways, and equipment, as well as making sure connections are made correctly and are mechanically sound. Thirdly, mounting and cooling of equipment, meaning electrical equipment must be mounted securely and in a manner that allows for adequate cooling. This is crucial to prevent overheating and potential equipment failure. Fourthly, access and working space, where sufficient access and working space must be provided around electrical equipment to allow for safe operation, maintenance, and repairs. This includes maintaining clear pathways and providing adequate lighting. Fifthly, guarding of live parts, in which live parts of electrical equipment operating at 50 volts or more must be guarded against accidental contact. This can be achieved through enclosures, barriers, or elevation. Sixthly, identification of equipment, where electrical equipment must be clearly and durably marked to identify its purpose, voltage, and other relevant information. This helps prevent confusion and ensures that personnel can easily identify and work on the correct equipment. And seventhly, use of listed or labeled equipment, in which electrical equipment must be listed or labeled by a recognized testing laboratory, such as UL or ETL. This indicates that the equipment has been tested and found to comply with applicable safety standards. Moving on to Article 240, let's discuss overcurrent protection. This section of the NEC focuses on protecting electrical systems from overcurrents, such as short circuits and overloads, which can cause fires, equipment damage, and other hazards. Some key aspects of Article 240 include: first, overcurrent protection devices, where electrical systems must be protected by overcurrent protection devices, such as fuses and circuit breakers. These devices are designed to automatically interrupt the flow of current when it exceeds a safe level. Secondly, selection and sizing of overcurrent protection devices, which means overcurrent protection devices must be selected and sized appropriately for the circuits they protect. This involves considering the ampacity of the conductors, the rating of the equipment, and any applicable derating factors. Thirdly, location of overcurrent protection devices, in which overcurrent protection devices must be located at the point where the conductors receive their supply and at other strategic locations throughout the electrical system. This ensures that overcurrents are detected and interrupted quickly and effectively. Fourthly, accessibility of overcurrent protection devices, meaning overcurrent protection devices must be readily accessible to authorized personnel for inspection, testing, and replacement. This ensures that maintenance can be performed safely and efficiently. Fifthly, enclosure requirements, in which overcurrent protection devices must be enclosed in cabinets, cut-out boxes, or other suitable enclosures to protect them from physical damage and environmental factors. Sixthly, disconnecting means, where each circuit must have a disconnecting means to allow it to be isolated from the power source. This is essential for performing maintenance and repairs safely. And seventhly, coordination, meaning overcurrent protection devices must be coordinated to minimize unnecessary outages and ensure that the smallest possible portion of the electrical system is affected by an overcurrent. This involves selecting devices with appropriate time current characteristics and coordinating their settings. We're turning back to section 110.34 that states the requirements for working space about electrical equipment. It focuses on ensuring that there is adequate space for personnel to safely access and work on electrical equipment. The specific requirements vary depending on the voltage of the equipment and the conditions of the installation. In addition to headroom, the NEC also specifies minimum dimensions for the depth and width of the working space. The depth of the working space depends on the voltage of the equipment and the presence of exposed live parts. The width of the working space must be at least 30 inches, but in no case less than the width of the equipment. It is important to note that these are minimum requirements, and in some cases, additional working space may be necessary to ensure safe and effective operation and maintenance. Now to discuss section 240.24b in more detail about dedicated equipment space. This section is crucial for maintaining the integrity and safety of electrical installations. It mandates that certain electrical equipment must have dedicated space around it, free from obstructions and foreign objects. The purpose of this requirement is to ensure that the equipment can be accessed easily and safely for maintenance, repairs, and inspections. Dedicated equipment space typically applies to equipment such as panel boards, switchboards, control panels, and other similar devices that require regular attention and servicing. The NEC specifies minimum dimensions for the dedicated space, including height, width, and depth. The height of the dedicated space must extend from the floor to a height of at least 6 feet 6 inches or the height of the equipment, whichever is greater. The width of the dedicated space must be at least 30 inches or the width of the equipment, whichever is greater. The depth of the dedicated space must be sufficient to allow for safe and convenient access to the equipment. It is important to note that the dedicated equipment space must be kept clear of any obstructions such as piping, ductwork, or storage materials. The only exception is for equipment that is directly related to the electrical installation, such as conduit or raceways. Furthermore, the dedicated equipment space must be adequately illuminated to allow for safe and effective work. The NEC recommends a minimum illumination level of 10-foot candles. In addition to the dedicated equipment space requirements, the NEC also specifies requirements for working space around electrical equipment. Working space is the area around electrical equipment that is necessary for personnel to safely perform tasks such as operating, maintaining, and inspecting the equipment. The NEC specifies minimum dimensions for the working space, including height, width, and depth. The dimensions of the working space depend on the voltage of the equipment and the presence of exposed live parts. It is important to note that the working space must be kept clear of any obstructions such as storage materials or equipment that is not related to the electrical installation. In addition to the physical space requirements, the NEC also specifies requirements for access to electrical equipment. Access must be provided to allow personnel to safely enter and exit the working space. The access must be of sufficient size to allow for the passage of personnel and equipment. It is important to note that the access must be kept clear of any obstructions, such as locked doors or gates. In conclusion, the NEC requirements for dedicated equipment space and working space are essential for ensuring the safety and reliability of electrical installations. By following these requirements, electrical professionals can help to prevent accidents and ensure that electrical equipment can be accessed and maintained safely and efficiently. It is very important to consider that specific requirements may vary depending on the voltage and type of equipment involved, as well as the specific local codes and regulations in effect. Always consult the latest edition of the National Electrical Code and any applicable local codes before beginning any electrical work. Finally, let's focus on Section 210.6 of the NEC concerning branch circuits, which is relevant since we are discussing electrical safety. Section 210.6 addresses the use of multi-wire branch circuits, which are circuits that consist of two or more unrounded conductors with a common neutral conductor. These circuits are commonly used in residential, commercial, and industrial buildings to provide multiple 120-volt circuits from a single 240-volt or 208-volt supply. The NEC permits the use of multi-wire branch circuits under certain conditions. The most important requirement is that the neutral conductor must be sized to carry the maximum unbalanced load in the circuit. This is to prevent the neutral conductor from overheating, which could lead to a fire. The NEC also requires that multi-wire branch circuits be protected by a multi-wire branch circuit breaker. This is a special type of circuit breaker that is designed to trip all of the ungrounded conductors of the circuit simultaneously. This is important because it ensures that all of the loads on the circuit are energized at the same time, which can prevent electrical shock. In addition to these general requirements, the NEC also has specific requirements for multi-wire branch circuits that serve specific types of loads. For example, multi-wire branch circuits that serve electric ranges must be protected by a ground fault circuit interrupter or GFCI. This is because electric ranges are often located in areas where there is a risk of electric shock, such as kitchens and bathrooms. It is important to note that the NEC is a complex document, and it is essential to consult the latest edition of the code before performing any electrical work. The NEC is updated every 3 years, and the requirements for multi-wire branch circuits may change from edition to edition. If you are not familiar with the NEC, it is best to consult with a qualified electrical contractor before starting any electrical work. A qualified electrical contractor will be able to ensure that your electrical work is done safely and in accordance with the NEC. The NEC Section 110.34 also covers the required depth of working space in front of electrical equipment. The depth of the working space depends on the voltage of the equipment and the condition of the installation. There are 3 conditions to consider. Condition 1 exists where there are exposed live parts on one side of the working space and no grounded parts or grounded surfaces on the other side of the working space. In this case, the depth of the working space must be at least 3 feet for equipment operating at 150 volts or less to ground, 3 feet for equipment operating at more than 150 volts to ground but not more than 600 volts to ground, and 4 feet for equipment operating at more than 600 volts to ground. Condition 2 exists where there are exposed live parts on one side of the working space and grounded parts or grounded surfaces on the other side of the working space. In this case, the depth of the working space must be at least 3 feet for equipment operating at 150 volts or less to ground, 3.5 feet for equipment operating at more than 150 volts to ground, but not more than 600 volts to ground, and 4.5 feet for equipment operating at more than 600 volts to ground. Condition 3 exists where there are exposed live parts on both sides of the working space. In this case, the depth of the working space must be at least 4 feet for equipment operating at 150 volts or less to ground, 4 feet for equipment operating at more than 150 volts to ground, but not more than 600 volts to ground, and 5 feet for equipment operating at more than 600 volts to ground. It is important to note that these are minimum requirements, and in some cases, additional working space may be necessary to ensure safe and effective operation and maintenance. The NEC Section 110.34 also covers the required width of working space in front of electrical equipment. The width of the working space must be at least 30 inches or the width of the equipment, whichever is greater. The working space must be clear and unobstructed. There should be no pipes, ducts, or other equipment in the working space. The working space should be well lit. There should be at least 10-foot candles of illumination in the working space. It is important to note that these are minimum requirements, and in some cases, additional working space may be necessary to ensure safe and effective operation and maintenance. Therefore, With the presence of the P-trap over the electrical panel, the risk of water dripping on the equipment or personnel working on it is not only a safety concern but also a code violation. The intent of the NEC is to provide a safe working environment for electrical workers. The dedicated space and headroom requirements are in place to ensure that workers have enough room to safely access and work on electrical equipment. By violating these requirements, you are putting workers at risk. As a result, it is advisable to relocate the P-trap so that it does not violate the dedicated space and headroom requirements of the NEC. This will ensure that the electrical installation is safe and in compliance with the code. Additional considerations include: first, local amendments, which is important to note that local jurisdictions may have amendments to the NEC that are more restrictive. It is crucial to check with the local building department to see if there are any local amendments that apply to your project. Secondly, engineering judgment, where even if the installation meets the minimum requirements of the NEC, it is still important to use good engineering judgment to ensure that the installation is safe and reliable. In some cases, it may be necessary to provide additional protection or working space to ensure the safety of workers. And thirdly, documentation, in which it is important to document all electrical work that is performed. This includes providing drawings, specifications, and calculations. This documentation will be helpful in the event of an inspection or if there are any questions about the installation in the future. Therefore, to further elaborate, consider the specific scenario of a 277/480 volt panel. This type of panel is typically found in commercial or industrial settings and is used to distribute power to various loads, such as lighting, motors, and equipment. Working on or near 277/480 volt panel can be extremely dangerous due to the high voltage levels involved. Contact with live parts can result in severe electrical shock, burns, or even death. Therefore, it is essential to take all necessary precautions to ensure the safety of personnel working on or around these panels. This includes wearing appropriate personal protective equipment, such as insulated gloves and safety glasses, and following proper lockout/tagout procedures to de-energize the equipment before working on it. Now let's consider the specific requirements for working space around a 277/480 volt panel. As mentioned earlier, the NEC requires a minimum headroom of 6 feet 3 inches from the finished floor or working platform. In addition, the NEC specifies minimum dimensions for the depth and width of the working space. The depth of the working space depends on the conditions of the installation, as described earlier. For a 277/480 volt panel, the minimum depth of the working space ranges from 3 feet to 4.5 feet, depending on the presence of exposed live parts and grounded surfaces. The width of the working space must be at least 30 inches or the width of the equipment, whichever is greater. In addition to these dimensional requirements, the NEC also specifies that the working space must be clear and unobstructed. There should be no pipes, ducts, or other equipment in the working space that could impede access to the panel or create a safety hazard. The working space should also be well lit to allow workers to see clearly and avoid accidents. Now let's consider the impact of a P-trap located above the 277/480 volt panel. A P-trap is a plumbing fixture that is used to prevent sewer gases from entering a building. It is typically located under sinks, toilets, and other plumbing fixtures. If a P-trap is located above an electrical panel, there is a risk that it could leak and drip water onto the panel. Water is a conductor of electricity, and if water comes into contact with live electrical parts, it can create a dangerous electrical shock hazard. In addition, water can damage the electrical equipment and cause it to malfunction. Therefore, it is essential to ensure that there are no plumbing fixtures or other sources of water located above electrical panels. If there are any such fixtures, they should be relocated or protected to prevent water from dripping onto the panel. In the specific scenario described, the P-trap is located approximately 7 feet above the finished floor. While this may seem like a safe distance, it is important to consider that water can travel a significant distance if it is dripping from a height. In addition, the P-trap may be subject to condensation, which could also drip onto the panel. Therefore, it is recommended that the P-trap be relocated to a location where it does not pose a risk to the electrical panel. In addition to the safety concerns, there may also be code violations associated with the P-trap located above the electrical panel. As mentioned earlier, the NEC requires that the working space around electrical equipment be clear and unobstructed. If the P-trap is located within the working space, it could be considered a violation of the code. In addition, the NEC requires that electrical equipment be protected from physical damage. If the P-trap is leaking, it could damage the electrical equipment and create a code violation. Therefore, it is important to ensure that the electrical installation is in compliance with all applicable codes and regulations. As a conclusion, the presence of a P-trap above a 277/480 volt panel poses both safety and code compliance concerns. It is recommended that the P-trap be relocated to a location where it does not pose a risk to the electrical panel or violate any applicable codes or regulations. This will help to ensure the safety of personnel working on or around the panel and the proper functioning of the electrical equipment. The risks associated with the proximity of a P-trap to a 277/480 volt electrical panel are significant and multifaceted. The potential for water leakage from the P-trap onto the electrical panel creates a serious electrical shock hazard, as water is an excellent conductor of electricity. This could lead to severe injuries or even fatalities for anyone working on or near the panel. The presence of water can also cause corrosion and damage to the electrical components within the panel, leading to malfunctions, equipment failure, and costly repairs. These repairs could involve significant downtime, impacting productivity and potentially causing financial losses. Furthermore, the installation may violate the National Electrical Code, specifically Section 110.34a, which mandates adequate headroom and working space around electrical equipment. This violation could result in fines, penalties, and the requirement to rectify the non-compliant installation, adding to the overall expenses. From an operational standpoint, the presence of the P-trap could obstruct access to the electrical panel, making maintenance and repairs more difficult and time-consuming. This could increase the risk of accidents and injuries during servicing. Moreover, the leaking water could create a hazardous environment, increasing the risk of slips, trips, and falls for personnel working in the area. In terms of long-term reliability, the continuous exposure to moisture could accelerate the deterioration of the electrical panel and its components, reducing its lifespan and requiring more frequent replacements. The potential for electrical fires is also heightened due to the increased risk of short circuits and arcing caused by the water. Finally, the overall safety culture within the facility could be negatively impacted, as workers may become hesitant to work on or near the electrical panel due to the perceived hazard. Therefore, relocating the P-trap away from the electrical panel is not just a matter of code compliance but a crucial step in ensuring the safety of personnel, protecting equipment, and maintaining operational efficiency.